We're back with lesson 42, but first I want to read you a little bit more of Psalm 116. Gracious is the Lord and righteous. Yes, our God is compassionate. The Lord preserves the simple. I was brought low and he saved me. Return to your rest, O my soul, for the Lord has dealt bountifully with you. So we need to just remember the source of all things and praise him. So let's go with our lesson 42C. We're working on exponential functions right now and what they look like. So I'm going to move this down just a little bit so that you can see the functions I have on the board as we work on graphing them together. Now, whenever we have an exponential function, we're going to graph y is equal to 2 to the x, which is a real good basic exponential to work with. Now, I'm going to put a 1, 2, 3 here. We're going to start putting our little grid of points here, x and y. And when we start to do this, if I plug in a 0, then 2 to the 0 is 1. Okay, when I plug in a 1, 2 to the 1 is going to be 2. When I plug in a 2, 2 to the 2, 2 squared will be 4. And I've got 0, 1, which turns out to be our classic point on all exponentials that are not translated. And then 1, 2, 1, 2, and 2, 4. 2, 1, 2, 3, 4. Now, what happens on the other side? If I plug in a negative 1, I'm going to get 2 to the negative 1, and 2 to the negative 1 flips that over and becomes a 1/2. So at negative 1, I get a 1/2. At a negative 2, this becomes a negative 2, which is the same as 1 over 2 squared, which is 1/4. So as I continue on, I'm going to get smaller and smaller, but I will never touch that line, and that is an exponential curve. Okay, so now that we've seen that one, let's talk about this one. Now, we have talked about some of the things that happen to our functions when we transform them, okay? And one of the things is when we're talking about a function and it getting a negative in front of the x inside the function, that normally flips the function across the y-axis. Okay, so it is a reflection across the y-axis. But what your section of the book is trying to show you is let's put these into a more familiar form. And the more familiar form than 3 to the negative x is to think, well, this is the same thing as 1 over 3 to the x. In other words, I can flip the whole 3 to the negative x down and make it 1 over 3 to the x, which is the same thing as 1/3 to the x. Now, would you agree? It doesn't matter what the x is. 1 to that number is still going to be 1, right? So 1 over 3 to the x is the same thing as 1/3 to the positive x. So that has changed the base of our exponent from a constant that is greater, that is a whole number, to a constant that is a fraction. Okay, and what does this do to the shape of the graph? When we start to make our little XY grid over here, and we plug in a 0, whether we plug it in here, whether we plug it in there, anything to the 0 power is going to give us a 1. And if we plug it in here, that's still going to be a 1. So 0 is still going to be that classic point, 0, 1. Then when we plug in a 1 here, we're going to get 3 to the negative 1, which is 1/3. When we plug in a 1 here, we're going to get 1/3. So at 1, the function becomes 1/3. And then if I plug in a 2, then this is going to become 1/9. And we can see that if I plug in a 2 there, it'd be 1 over 3 squared, which is 1/9. So when I come over here too, it's just getting closer and closer. So we figure that what's probably going to happen when I plug in a negative 1, that it's going to grow, right? So I plug in a negative 1, that's going to be 3 to the negative a negative 1, or 3 to the 1, and it's going to go up to 3. So negative 1 will be 3, negative 1, 1, 2, 3. And that's where our function is going to, grow exponentially. It's growing to the left, which means that it is actually a declining function. Okay, so this is the type of form you will have when you have a negative exponent on a integer base. Okay, now notice my little definition up at the top of the board. It says in exponential functions, the exponent contains a variable and the base, two qualifications for the base. The base is greater than 0 and cannot equal 1. What would happen if this base over here was a 1? If the base was 1, it would be 1 to a power, and no matter what I gave the power, it would continue to be 1, wouldn't it? So it would not have an exponential curve at all. All right, let's look at this one. And let's think about another function that would help us to evaluate it if we were going to y is 1/2 to the 2x is the same thing as y is 1/2 squared raised to the x. Remember when I raise a power to another power, I just multiply. So this is the same thing as 1/4 to the x. All right, now I already looked at what 1/3 to the x was going to look like, and it is a declining function. So I figure 1/4 to the x is also going to be a declining function. And when I put my little x's and y's in here, and I start plugging in my 0, I will still get 1. When I plug in my 1, I will get 1/4. When I plug in my 2, I will get 1/16. When I plug in my -1, I will get 4. So this function is going to look a lot like this function. Still goes through 0, 1, 1 and 1/4, 2, ooh, it's getting real small, and then on the left, -1 and 1, 2, 3, 4. So it's going to decline to the right as it approaches that asymptote there, okay? Now, this one over here I have is a little bit more complicated. Try to get that straighter for you. Okay, y is equal to 1/2 a negative x minus a 2. So when we start to think of translation or transformations of formulas, what would happen if I had a parabola that had a negative in the front of it? Well, if you had a negative on the parabola, it would probably be going down, but this negative is inside the function. So just think of what we talked about when we had the radical with a negative x in it. With the negative x inside the function, it flipped it over in this, and isn't that exactly what's happening to these functions? Here was my classic 2 to the x, and when I had a 3 to the negative x, it is reflected across from there to there. It's reflected across the y-axis. It's like it's flipping over here. Okay, so let's see if I can place this down here if you can still see. So when we're looking at this one, what shall we do? First of all, we're going to make our little XY grid. All right, but we're going to suspect that this is going to flip across so that it will also be, since it's 1/2 to the negative x, that would be the same thing as what? Could I change this around? 1/2 to the negative x plus 2. Could I do that? All right, well then, could I flip this one over and say that's the same thing as 2 to the x plus 2. I took that negative and flipped the whole thing over. And when I look at that, I say, oh, this one is a 2 base, so that should be increasing as it goes to the right. And this is a translation. It should be going 2 steps to the left. So I'm not going to expect my function to cross at 0, 1 anymore. That classic point is going to go away because this thing is being translated or shifted over 2 steps to the left. All right, so let's check and see if what I'm saying holds water. We have an x and a y, and we're going to do it both into this one and into this one just to make sure I didn't make any errors. So if I plug in a 0 here, I'm going to get 1/2 to the, that's going to be a 0, to the -2. And what is 1/2 to the -2? Well, it's going to be a 4, isn't it? Okay, and then if I plugged in a 1, I'm going to get a -1 minus a 2. That's a -3. And 1/2 to the -3 is an 8. Okay, so this one is increasing as we go to the right. 0, 1, 2, 3, 4. It's not a 0, 1 anymore, is it? And a 1, 8. So it is increasing. Okay, 1, 8. Now, since it's increasing to the right, let's look and see what it does to the left. -1. When I plug in a -1, this right here becomes a +1 minus a 2, altogether a -1, and this is going to become a 2. 1/2 to the -1 is a 2. -1 is going to raise it to a 2. Okay, and then a -2 is going to make this a -2, which is a +2. Minus a 2 is a 0. Anything to the 0 is a 1. So -2, 1 is that special little point right there that should have usually been there, but we've slid the whole thing over. And that is going to continue to decrease to the left. Okay, and this is the same thing we would expect it to be. Notice that that special point, that 0, 1 point, has been shifted over to -2, 1, and that's what we would expect that to do. So when we look at the two functions, all right, we did, this one is the same thing as this one, okay, oops, same thing as this one, and notice this graph, and when we walk over the board and we notice this graph, which is y is equal to 2 to the x, it had the same points over here, right? It had 1, 2, 2, 4, -1, 1/2. If I'd gone further to the right, if I plugged in a 3, I would have gotten an 8. Okay, and then over here, those points have been shifted over. So instead of a 0, 1, I have a 0, 4, I have a 1, 8, I have a -2, 2, -2, 1. Same general shape, shifted 2 spaces to the left. Okay, and we